For the CircuitPython Parsec today, I wanted to show you how to do an analog read using the Seesaw chip over I2C. So we are continuing the series here on having GPIO that is local to the little board, and then Seesaw chip sending all of its little reads that it does over I2C to your microcontroller. In this case, I've got a QT Py RP2040 running CircuitPython, of course. And this is, again, this little Gamepad QT board, which has 6 buttons on it, and we looked at some digital I/O stuff last week. This time we're going to talk about this little thumbstick, which is a set of small potentiometers. So what's going to happen here is we're going to import Seesaw so that we can do all that little local stuff as well as send those messages over I2C. I'm setting that up on the Stemma I2C bus. And then I'm creating the Seesaw object by saying Seesaw, I2C bus, and then the address of the Seesaw chip bearing board. In this case, address is 50. Now, the next thing that I'm doing is just printing out a little information to the REPL and setting a state variable for the X potentiometer and the Y potentiometer, which is what's inside of this little tiny thumbstick here. Then for the main loop here, what I do is I set this variable x to be equal to 123 minus the Seesaw analog read on pin 14, and then 123 minus the Seesaw analog read on pin 15. So those are pin 14 and pin 15 analog potentiometers, but this would work with any analog thing that you're trying to read. Then we just check for a little bit of a change, as long as, just so it's not too noisy, as long as the reading that we get is 3 away from the last state on last X and last Y that we checked, then we'll go ahead and proceed with outputting the little string format here. So this is setting up a nice string that I can print to the REPL without my REPL flying by. That's what this jazz is about here. And then the X from this X read with 4 digits, and the Y from this Y read with 4 digits is going to get printed, and then this little escape character /R keeps that all on one line. And then after we've done all of that, read, print, and then set the new baseline to the current position, and a little tiny sleep there. So you can see here at the very bottom of the REPL, it says 0 if I go far left, 123 if I go far right, and around 512 or so in the middle. And then up is around 1024, and down is around 0. So you can see just moving this little, I call it thumbstick, I should use my thumb on it. Moving this little stick around, we get the analog read. However, there's no GPIO being used on the QT Py. Instead, we're getting these over Seesaw. Now, in this case, that's not a ton. It's 2 GPIO pins. However, when we go ahead and add in all of these 6 buttons here, we can have some nice efficiency. Oh, I just blew it up by pressing one of those buttons. Let me restart that. We can have some nice efficiency by doing the reading off board on the Seesaw chip, which is prepared for all this GPIO, and send that over I2C, which means we've left the sort of minimal number of GPIO pins alone on the QT Py. So if these are plugged into a whole bunch of other stuff on your project, we've now saved ourselves about 10 different GPIO pins or so using Seesaw and I2C. And that is how you can do an analog read using Seesaw inside of CircuitPython. And that's your CircuitPython Parsec.